Timas TV. Today we are looking at examples on partial differentiation. We have 4 examples to deal with, and we are going to start with number 1. Number 1 says that if z is given as this, cos sine this, that we should show that is equal to 0. So at this point, we are going to employ the concept of partial differentiation, and we are looking at dz dx first. So at this point, we are trying to handle this using the product rule method. So this is multiply with the differentiation of this with respect to x. So this is giving us cos y, whereas this is 0, plus we are going to maintain this minus y sine 1 and differentiate exponential x, and it's still exponential x. So at this point we try and simplify the solution. So this is cos y plus x cos y minus this. This is in brackets multiplying exponential x. So at this point we can further do this, simplify this, and we are left with cos y plus x cos y minus y sine y. That is the answer to differentiation of x with respect differentiation of z with respect to x. So, but we are looking at the second derivative with respect to x. So we'll further do this. So this is giving us dz dx. So we have gotten this already. It's going to be this into exponential this cos y plus cos x cos y sine y. So at this point, we are going to differentiate that with respect to x. So we can keep this exponential x and differentiate this with respect to x, and this is giving us this is 0. This is cos y, and also this is 0 because y is a constant at this point. So multiply this plus, I'm going to keep the whole of this cos y plus minus this, and differentiate is giving you that. So we try and factorize the answer. So this is going to give us exponential this plus this is 2. So we have it 2 cos y plus minus sine y. So that is the second derivative of z with respect to x. Also, let's look at with respect to y. So z is given as this x minus sine x. So partial differentiation with respect to y is If you're going to maintain this exponential x and factorize this, so this is giving us minus x sine y and minus into this cos y plus sine y dot 1. That is, we differentiate y. At this point, you're having this. When you multiply sine y with this. And also, if you return this and differentiate this, you're having cos y. So that is why it is like that. So we have that exponential x so plus we keep this cos y sine y multiply with 0 because an exponential x is constant. So we have that dz dy is giving us exponential x into sine y minus x sine y, and sorry, this is minus all of this, minus sine y minus this, and we have minus y cos this. So because of the question, we are looking for the second derivative of that, so we can clean this so you can have a space. So at this point, we further differentiate with respect to y, and this is giving us that exponential x into this is minus cos y, and this is minus x cos y, and also this is product rule. We have to handle it such. So we open the bracket. You can keep y and differentiate this. We have minus sine y, and also plus. You can keep cos y and differentiate y to have 1 plus. We also maintain this minus sine y minus x sine y minus cos this, multiply the whole of that with 0. So at this point, we can simplify the equation. This is 0 exponential x into minus cos y minus x cos y. This is minus, that's plus x sine y minus cos y. So if you further demonstrate it, we are having this plus this is 2. So exponential x into minus 2 cos y minus this plus this. So we have gotten what we were looking for. It is left for us to act and see if we are going to have what we asked to prove. So at this point, we got this and this. So the addition of this will give us what? So let's look at it. The addition of the both component and see what we are going to have. So this with respect to y plus this with respect to x, we have this. So this plus this giving us 0. This plus this giving us 0. And this plus this giving us 0. So at this point, it is proven that the second derivative with respect to y adding with respect to x is 0. That's proven. And we are going to the second question. The second question, let's solve the second question. We are having that if z is this, that we should show that this plus this equals to this. And the hint is that f is arbitrary function. So at this point, we will write this out. Z is plus this, y divided by that. So let's do it with respect to x. And we have x here, we have x here, then we are treating it as product rule. So we can retain this and differentiate this. So this will give us minus we further differentiate the function as we have in prime. So we add it with retaining just this, and we factor and differentiate it with respect to x. We have 1. So in this case, we have that dz, the x is this, that is minus y divided by, and we can also notice that we needed to replace this with the right thing. So we can let's resolve that. This guy will do this. So number 2 question is that we are saying that z is given as this, and we have to prove that the addition of this will give us z, where f is arbitrary function. So at this point, let's do this. We keep this and differentiate that. And differentiation of this is actually y divided by this. And we have to do that. We will add it, and we are saying that Okay, let's solve for a number 2 question that the z is equal to this, and we also prove this. So at this point we have the z divided by the x. We can treat this as a product rule where we can keep this and differentiate this. So this will give us minus y divided by x squared, and we can further differentiate the function. That's why we're having f prime. So we plus also keep this and differentiate that. That's why we're having 1. So the x to the z is giving us this minus into y divided by this prime plus f this. So, and if you look at what we have to prove, we are looking at this component. So at this point, we can multiply this. This will give us minus x plus this, y divided by x. The x has cancel 1, we have 1. And we have this plus x, that. So at this point, we have that. So looking at with respect to y, we can also treat similarly. We have this. This will give us 1 divided by x, and we can also differentiate the function. We keep this and differentiate this with respect to y. We have that. So this is giving us this plus this prime plus this. So at this point, we can rearrange. Okay, let's look at what we're given. Y is multiplied. So let's multiply y with this. So this is giving us this dot y divided by x prime, and that multiply y here, we have this. So at this point, we are having to add to see what we are going to given. So y, the x, the y plus x, the z, the x is actually this plus this. So this this prime plus this x, y plus bracket this y divided by this prime plus this. So at this point, we can erase some parts. This will cancel out. This cancel this. So we are left with this. This is equals to plus. So when we factorize, we have this. So it means that this is equal to z. Z was given as that. So that is the answer to number 2 question. Um, Number three question, let's see how we're going to handle number three question. We are given that f is this, whereas x is r and y is this. So we are asked to prove that 2y equals to minus x. So let's see how we can go about this. At this point, we are saying that x is this and y is this minus. So with respect to x, r, we are having exponential theta. With with respect to r here, we are having this, and also x with respect to theta, we are actually having the same thing, and y with respect to theta, we are having the same, but minus in this case because of this. So we should also take note that our dy dx from here is y and y, and we have it. Also this is y and we have it. We have this. So the f divided by the r is the same thing as the r, the x, the r plus the f, the y, the r. So we look at that and just substitute what we are having. So at this point, the f, the z is this. So we have this. Multiply this with the x, the r. The x, the r is this. Also, this is this. And multiply that with the y, the r. The y, the r is this. So we can actually simplify this to have simplifying this, we have this prime into y plus x. That this is the y, the r. And similarly, let's look at the f. This is the f, the r. Let's look at the f, the theta. The f, the theta, we are having the same procedure. It's going to be the f, the x, the f, the theta, plus the f, the y, and the f, the theta, the y, the theta. So So at this point we can substitute. Let's substitute this. We're going to have the f, the theta. This is y f prime. The x, the theta is this, and also the y, the theta is that. What? Let's work on this. So this is x, y prime. So this becomes this minus that. So we can actually further simplify um, this expression so that we can have something like this. So the f, the theta is actually going to be the f prime into y, that is multiplying this with the minus and multiplying this with that. So you have x r this. So you are still looking at the what we're given. We're asked to multiply r with that. So we got this, and since the the r is actually this prime into y exponential this plus x exponential that, multiplying with r will give us this into this r plus this r. We have that. So in this case we have gotten this, we've gotten this, and we've gotten this. The next is this. So the next is that the f dy is actually x prime this, and 2y of that, 2y, the f this is actually 2y x prime this. So let's see how it is. We are saying that this is the same thing as this. So let's see how it's the same. We've gotten these two. Let's see how we can find the solution to this. So this is giving us, and this is giving us, so r is equals to this prime into yr exponential this xr exponential that, that is this minus f prime, it is y into y into yr exponential minus xr exponential this. So let's see how we can simplify this. We can do that by factorize this out, and we are putting it this out plus this minus out this plus xr plus xr. This is minus all that. So we have this and we have this. So this is giving us this. This will cancel this, and we have this plus. We have this plus this. We have two of that. So let's look at what this is. Let's look at what this is. But we are also given that y is equals to r exponential this. So in place of this, we can actually replace and say this is equals to 2xy. So when we look at this, comparing this and this, we have actually successfully proved that 2y divided by x is actually r the r minus this the theta, and that is proved. Yes, looking at the fourth equation, the fourth question, we are trying to prove that if v is given out this, that the addition of the second derivative of the both parameters will give us 0. So at this point, let's see how to prove this. This is in plus this, and dv dx is giving us 2 divided by x plus this, and also dv dy is giving us 2y divided by this. So what happened to the second derivative of them? So d squared v is actually this into dv dx, and this is giving us that the second derivative with respect to x, we can keep this as quotient rule, d squared plus this, differentiate that, we have this minus. We can keep 2x as, and do this with respect to x, we have into x. Divide the both of them with this into that. So we can further simplify the equation, and that will give us 2x squared plus 2y squared minus 4x squared. All this divided by this plus this squared, and the answer is giving us 2y squared minus 2x divided by this and divided by that. So that is the second derivative with respect to x. So we have this for y. This was given as this divided by this and this. So the second derivative, using the same procedure with respect to y is actually this is x multiplied by 2 minus 2y, this divided by this and this all raised to the power of 2. So at this point we can um, work on the final solution. This is 2x plus 2y minus 4y squared divided by this. So this is, which is this plus this. So we're having this minus 2y squared divided by this. So let's add the two together. We're adding this with respect to y plus this with respect to x, and this is giving us this is giving us 2 minus this divided by this squared plus this. So we have 2 divided by this squared. So let's simplify the whole expression. It's going to be 2 minus 2x squared plus 2x squared minus 2y squared. All this divided by this squared. So this cancel this and this cancel this. We're having this divided by this. So we actually is actually proven. This is this plus is actually proven that this is 0. So hence this x equal to 0. So thank you very much for watching that video.